Hi, everybody. First, thank you for having me. I want to clear up any misconceptions that may be there. I'm not a Masters champion. That's Tiger Woods. I wear this to remind everyone and encourage everyone to think green in your day-to-day activities. We've got a lot of changes to make in the world and in our network infrastructure in order to be able to withstand the challenges that are coming in the decades that will pass, to make sure that our systems don't fail. So in that thought, in 2003, my networks, it wasn't big, and it's still not big. I had my mail servers, my name servers, those types of things on my rack, a couple of web servers. Hurricane Francis came and just knocked me over. No power, no network upstream, no nothing for weeks. And it was really debilitating. So at that point, I started building SolarNet 1. We got some solar panels and some batteries, and we did some work to make the network hosts efficient enough that we can do that on a small scale, both economically and with 5 nines of uptime on the power supply. And I thought, great, I'm all set. The next hurricane comes, I'm not going to have a problem. And so then the next hurricane came, and it knocked me over again. Only it didn't knock me over, it knocked the upstream carriers over. And I can't fault them for that by any stretch of the imagination. Nobody is prepared for those type of events. All of you network operators, I'm sure, have to deal with situations like fires, earthquakes, hurricanes, tornadoes, flooding, particularly recently, and the effects upon your networks and mitigating those effects. So I said to myself, okay, well, looks like I have to actually up my ante here on the network side and go get some IP addresses and an AS and multi-home my site, so that when one of my upstream carriers goes down, my rack doesn't go down with it, because I sat and kind of rode out Hurricane Matthew. I was in Colorado at the time, but my networks just kept running because of the large battery bank and the solar power array, et cetera. So I said, okay, let's see what we can do. Got back from Colorado, and then the next year, Hurricane Irma comes and says, nope, you're going down again. Same reason. Upstream connectivity fails, I'm getting my IP addresses from them, and now my rack doesn't work anymore. Sure, I can use my redundant connections to get kind of user level services, call for help and things like that, but the core of my communications infrastructure was down. So I'm now kind of on the journey of solving this problem, and when I look at it, I say, okay, we've got a large number of ASs in my general area, some small network operators, some universities, municipalities, those types of things. Some of these will stay up for an extended period of time because they have generators, and some will fail because they can't get fuel to those generators. Some have various assorted network connections that are going to fail notwithstanding because of damage to lines or other similar kind of outages. The goal of the whole project is to make it all resilient, so that not only me, my small operation, but emergency services, other enterprises and small businesses can stay up, or at least not have to do major repairs to their networks to recover from these natural disasters. If we can keep everything up, that's great. If we can minimize repairs, well, that's probably acceptable at this point, because everybody is doing a lot of things when a hurricane comes and knocks you over, or when a tornado swipes through your town, when the river is 5 feet too high and now you've got a problem with some of your underground cables and things like that. In this process, what I found is that it's very difficult to encourage some of the carriers that are going to be connecting these small businesses and other entities to do a simple network peer to announce address space and provide that redundancy that is built into BGP. And of course, BGP in this room to most everybody means, okay, we're going to go into the IX, we're going to connect to everybody else, we're going to have all our routes, we're going to be good. But there's the additional use case that was built into the spec originally, which is to provide a multi-homing redundancy to the networks to prevent this type of thing. So this is a technical challenge that's already been solved. But in order to actually route the packets correctly, we not only have to have the edge carriers cooperate with that, Well, we need to either have that, or we need to have some methodology by which we can tunnel to internet exchange points and or other NAPs and NOCs that can terminate that traffic and send it out to its ultimate destination. And this is kind of the point of my talk here, is that we need to evolve our view of BGP a little bit and take it out of the data center and put it out onto the edge. Not in all cases, not in any of your cases particularly, except those carriers who are providing end user services and things like that. All you guys need to do is be a little more receptive to being able to peer with your standard customer, because he needs to be able to make redundancy happen. He needs to be able to ensure that his networks stay up. In some cases, this isn't going to be possible, I understand. I've had situations where carriers say we won't do it. I've had situations where carriers say we don't have the infrastructure in place to be able to do it, even if we wanted to, but we're willing to look at it. So the solution that I've kind of come to is that it's going to be very expensive for many small operators to build into exchanges and connect in a traditional fashion as they would in the IXP. So if we can take and make a situation where the small operator can tunnel to this data center, and this data center to announce his addresses and route his traffic, then over a standard, commercial class network circuit, then it will make it much easier to provide a robust solution to that customer. If we can encourage through the community, on a community scale, even a microwave link between two ASs can provide connectivity to one if the other fails in any of their upstream connections. So in the interest of keeping emergency services, small businesses, and other things that the communities rely upon as functional as possible in the case of the ever-increasing natural disaster events, I would encourage all of you to do everything you can to help those operators who are trying to make their systems redundant, push BGP out to the edge, and allow the redundant function of that was built into the specification to be enjoyed by a wider range of network operators other than just, I see the top of the pyramid of networking in this room. I understand all of you guys having multiply redundant power systems, multiply redundant connections to everything. You have it all automated and very well organized so that it doesn't fail, and that's great. But when the end user still can't use the network when he really needs to do it, that's when we need to push the engineering a little further out and try to accommodate that. That's really kind of all I have to say. If anybody has any questions, I think we are holding those till the end. So I'm going to yield whatever minute 43 I have left to the next speaker. Thank you, everyone. I appreciate your time.